Hi, this is Andrew, MTR1201. This is the Millie's Flying Fish sensor calibration module. So basically we've got the same setup as we had in the previous videos, and now we are programming to calculate the fish's actual angle using the gyro. So basically what we've done from last time, the bias from the sensor reading coming from the IMU has been, the average of that value has been calculated and has been subtracted from the sensor value reading to try and get that value as close to zero as possible. And then that's also been multiplied by the scale for the sensitivity setting for the IMU. Then that has been integrated using the start and end time of the loop to hopefully give an angle value that indicates where the fish is in relation to its set point. So currently the set point in the program is 0 and we are set on 0. GZ has been used for this one. I did try looking at GX and GY, and as indicated in some of the lectures, GZ was definitely the most stable. Still not perfect, but much closer to the 0 value that we were looking for. So if I just reload the program, clear the serial monitor. Go through our load up. So we've removed a bias of 127. And as we can see, they're not 0, but we're sort of averaging 3 to 4 degrees away from 0, which is not ideal, but still reasonably close. There are definitely a few outliers still popping up. So if we go, I will move to 15 degrees, and then we get that single jump there. So we got 11 there. Still finding they're roughly about 4 to 5 degrees off. This is from the set point, so it only reads when we've actually moved and not continually the angle that it's at. Go back to 0. See the movement of the sensor there, saying that it moved back approximately 16 degrees, and now we're back around that 1, -2, 0 sort of range. And then if we move in the other direction, see there we're at -15 degrees, which is fairly close to where we're at. So that's the readings that we're getting currently. Obviously, to end up having the fish trying to retain its position from a set point, the next steps will be to obtain the output value that can be sent to the servo. We'll do this by calculating the error and using the PID control techniques, factoring KP to the error, factoring KI to the integral, and KD to the derivative. And then the sum of those should hopefully give us an angle in relation to the set point for the servo to adjust to. And then obviously KP, KI, and KD gains will then have to be adjusted to smooth the step response and hopefully get it doing what we want to do. Thank you very much, and I will see you in the next one.